Hi, in this video I want to show you how I make this water dispenser with water inside that is not part of the mesh. It's made by shader. So this video is a use case for my previous video when I showed you how to use virtual plane coordinates. So let's begin. Before we start with the main shader, let's talk a little about other files. So I made two meshes, the water dispenser body and the tank. So let's go inside the body. And as you can see, the geometry for this one is quite dense. That's because I'm using nanite. So for nanite, the geometry like this, when you have dense quads with the same size, is very good. That's what nanite likes. So if I go away, you see it's decimating the geometry very, very well. So let's go back. Also, I have some textures, like ambient roughness metallic in one texture, base color, and normal map. Same for the tank. Here I have the material for my water dispenser. It's very simple, just plugging some textures. This one is from my previous tutorial, so it's a simplified version of this one. So we have the fake surface inside the ball. So if you didn't see that, go and watch it. And this one is our main shader for this tutorial. So here we have some liquid related logic, bottle related, some details and blendings. I'm still trying to keep my materials as simple as possible so you can learn something from them. So if you want, you can easily add some details like bubbles or something. So I'm just trying to keep my tutorials simple. Let's start from the bottom. So here I'm calculating my virtual plane UVs. I'm using for it the node that I showed you in my last video, so virtual plane coordinates. It's existing in Unreal Engine by default, so you can search for virtual plane and you will find it here. So if I preview this one, you can see it's generating the plane inside my mesh with own UVs, and I can move with my camera above it or under it. So to make it, we need some information, like the normal of our plane. In my example is 001 because it's pointing upwards, because it's a water. And the plane x-axis, which is like a tangent. By default, it's the x-axis, if I'm correct, and I'm also setting it as a x-axis. And for the plane center, this is a position of my plane in a world space. So I'm taking the object position in a world space, so it's always gonna follow my object. I'm breaking the vector, the position of it, because I want to change the b by my water level. And then I'm taking the object local bounds, the b channel, so it's a height of my object. I'm multiplying it by my liquid level. Liquid level is just a simple parameter, 0.5 in this example, and the water is in the middle of my mesh. I need to add offset to it because by default it's gonna be on the top. So I'm just offsetting it by half of my object. And then I'm multiplying it by my local bounds and by scale because maybe I want to scale my object for some reason. So it's always nice to add object scale multiplication to your logic. And then I'm adding this value to my object position. So we are getting the position always stuck to the object position, and I also can change the water level with this simple parameter, like this. And from that we get we're gonna get two values. I mean 3 values, but I'm using only 2: the UVs and the world position centered. So the world position centered is just a position of each pixel related to my water plane origin. Next part will be to draw the surface of our liquid on our virtual plane. For that, I'm using a sphere mask with the virtual plane world position centered as A, and B will be 0, so no offset. And if we preview this one, you can see the sphere is drawn on our virtual plane. For the radius, I'm taking the object local bounds, the G channel. It doesn't matter if you take the G channel or the R channel, it's gonna be the same value because the object is round. But as you may know, the object local bounds will give me the radius of those points because I have the hills and valleys on my mesh, on a silhouette. So the object local bounds will give me the hills value. So in places like this, I need to shrink my radius somehow. So besides of the object scale, I'm also using this vertex scale value with the vertex interpolator, which basically change the vertex value to the pixel value. But if I skip this one and look here, you see the radius is bigger. now it's smaller. So I baked those differences in Blender using geonodes, and I'm gonna show you how I did it now. Okay, so here is my setup in Blender. So I have my mesh and some geonodes. So the idea is, let me click this one. So the idea is to take each vertex and calculate the distance between the vertex and the value on the same height, but from 0, 0, 0, so from the world origin. So for this vertex, it's going to be distance from here to here. From this one, it's going to be from here to here. So I can multiply this value by my radius. So it's going to shrink and grow, depends on the distance from the vertex to the middle. So, because my IDs are very random, I took the position of my vertexes, the Z channel, and I sort them by that. So now the vertexes on the bottom will have very low value and the vertexes on the top will have high value. After that, I'm sampling the position value of each index and I'm adding it to the Z channel of my 0, 0, 0 point. So as I said, 0, 0, 0 point is here. Then I'm taking, for example, this value, this height value, and I'm creating like a empty point here, and then I'm calculating the distance between this point and this point. And same for example for this, from here to here. So this value will be a little bigger and this will be a little smaller. Then I'm taking the maximum value of it, so like here or here or here, and I'm remapping those values. So from the 0 to the max value. And I'm remapping it to 0 to 1 so I can easily multiply it in Unreal Engine, my radius, my maximum radius. And after that, I'm saving it as a vertex color attribute here, and I'm exporting it to Unreal Engine. Back to the shader. So after my sphere mask, I'm creating 3 other masks. So my first one is like the base for the surface. So if I preview this one, you can see it's almost flat color with some gradient in the middle, so it's darker here. So it's like a fake depth. And for that, I'm taking my sphere mask, which looks like this, and I'm using the bell curve to make the gradient more round. So if I preview this node in a moment, try to spot the difference. It might be hard to see on the video, but you can try it on your own Unreal Engine project. So let's preview this one. And the gradient now is more round. So I'm taking this value, I'm remapping it from 0 to 1 to 1 to 0.5. And I'm multiplying it with my save value, which is a flat color. And it's just giving me this mask. For the second mask, it looks like this. So it's a flat color with the smooth edges. I'm using this smooth step node with the very low value on the max. So it's giving me almost same color on the whole mask and a little gradient on the edges. And for the last mask, it's a ring. I'm using my previous smooth step node and I'm subtracting from it the second smooth step node, but this one have the greater value in max. So if I subtract one from the second, I'm gonna get something like this. So black color, gradient, white color, and gradient. Next part is optional. So here, I'm taking my camera position in world space, the Z value, so from bottom to the top. Same for each pixel value, and I'm subtracting those values. So I'm gonna get something like this. If my camera is above the pixel, it's gonna be white. If my camera is below pixel, it's gonna be black. So I'm using it to clip the water's surface. So for example here, as you can see, I can see my surface from the top, but I cannot see it from the bottom. But as I said, it's optional. If you want your surface to be visible from the bottom, you can skip this part. Okay, so water plane is done. So now we can work on the sides of our water. I'm taking the bounding box based UVW, the B channel. So it's a gradient from the bottom of my mesh to the top of my mesh, the 0,1 gradient. I'm adding to it my liquid level with the 1- node. So it's 1 minus and the value of the liquid. So in this example, 0.6. And then I'm using the floor node. So I have this black and white values. And if I move my liquid level now, you can see those values are representing the level of my water. Also, I'm using the frag. So because of frag, I have this gradient. It's always tagged between 0 and 1. I'm also multiplying it by itself. So it's like the power of 2. Just to make the gradient, let's say, like it's artistic choice. So it just looks fine for me. I prefer this version than this. So that's the only reason. I'm inverting my float by using 1 minus. So now the white values are on the bottom, and I'm multiplying those two values, so I'm getting the gradient. So if I change the liquid level value to 1, you can see I have nice gradient that is faking the depth of my liquid. And I'm saving it as my own reroute node. Normals are a little tricky because of this node, but let's start from the beginning. I took the 001 vector, which is a standard tangent space normal map vector in Unreal Engine, and I'm lerping it with my mask, the smooth edges mask, with the value of the same tangent space normal vector, but the half value of it. And the problem is that this value is not normalized, but the normal vector should be always normalized. And I did it because I wanted to have some difference between my bottle normal and my surface normal. And it's not something that you should do, like I guess it's a bad practice, but in this case it worked, so I did something like this. But maybe you will have a better solution for that. After that, I'm using the blend angle corrected normals. So I can blend my normals with other normals that I've made using some panel and textures. So let's go to the wave normals. Here I have two texture samples with the default normal map wave texture from the Unreal Engine. Some panels, so I can move my texture along X and Y axis. The virtual plane UVs, we've made them here. And I'm multiplying this UV's value with the object scale divided by other value. So basically it's because if I scale my object, the waves will scale also. After that, I'm blending my normals. I'm also adding flattened normals, so the waves will be not as sharp as the texture is by default. And I'm adding it to my other normals. Okay, little update for the liquid normals. So instead of taking the 001 tangent vector and multiplying it by half, you can do something like this. So take the 001 vector, transform it from the workspace to tangent space, and lerp between those two values with alpha like 0.35, and use this as a B. So you will have more highlights on your water. For the bottle color, I'm taking the texture of my bottle and I'm lerping it using Fresnel with the second value is the texture multiplied by 0.25. So because of that, I will have those highlights on the edges. And I'm saving this value as a bottle color named reroute. And after that, I'm creating my fluid color here. So I want my fluid color to inherit the color from my bottle. So that's why I'm using this lerp. And the color will be mostly bottle because the alpha is 0.2. So if I change my fluid color to something like a green or maybe a red, it still inherits the color from the texture of the bottle. If I disable this lerp, it's gonna look fake. Next part is blending. So blending is very simple. We start with our surface only visible if camera is above the plane. So I'm taking my liquid surface clip mask and which looks like this, if you remember, and the surface only mask, which looks like this. I'm just multiplying this value with each other. So now I can see my surface if my camera is above it, and I cannot if my camera is under it. Then I'm saturating it because it's always worth to use the saturate to keep your values between 0 and 1. And then I'm combining it with the side mask. So I'm taking my side mask, which looks like this, and I'm using the max to just add them to each other. I mean, it's not adding, it's taking the highest value. And I'm saving this as a seal value. So it, oops, sorry. So it looks like this. And the second value is the surface only. Next part is a artistic choice. So I'm taking my fluid color, I'm multiplying it by my fluid mask, and after that I'm lerping it with my ring. So here is my ring. I'm lerping it with the value that is higher than 1, so it's 1.25. So the edges are brighter than the water surface inside. I'm saturating this value, and after that I'm adding the bottle color to my liquid color using the mask that we just created here. So this is my mask for the lerp, and this is final output. The bottle color and the liquid color combined. And the last part of my material is some PBR values. So for example, like a specular roughness, subsurface scattering. And let's go here. Let's start with the textures. So here I have two textures. One is a normal of my bottle, and one is the ambient and roughness. So I save them as a name tree root because it's always good to organize your nodes. And let's start here because we already talked about normals. So for the specular, I have just my mask, my liquid mask, and I'm using it as an alpha between 0 and half and the custom parameter, so I can change the specular of my water. For the roughness, it's mostly the same. So I'm taking the water mask and I'm lerping between my texture roughness and the water roughness. For the subsurface scattering, the same thing. I'm using my mask and I'm lerping between my liquid subsurface and the bottle subsurface. So it is taking my final color from here, and it's multiplying the value by some other value, by the parameter. And the last one is a normal map. So here I'm taking my normal map, the texture, and also my normal map from here. Sorry, not from here, but from here. And I'm lerping it using my surface only with between the texture, which looks like this, and my surface normal, which looks like this. But because I have some overlapping normals here, like you can see here, I'm using the flattened normal of my texture normal with the blend correctly normals and my surface normal to blend my surface normal with a little normal from the outside. And after that, this is my final color, my final lerp normal. So yeah, you can even change the value of the normal flatness. But the problem here is that you can see that the normal map here exists, but it doesn't exist here on the inside because this material is not transparent. And yeah, that's all. And that's it for this video. So this tutorial took me a lot of time to make, so I will be very happy for every like, subscription and comment. And if you have any idea what kind of effect I could make, just type it in a comments. So see you next time.